Hello, you're welcome to Maths Clinic series. In this video, we want to look at significant figures, the concept of significant figures. This video has become very necessary because a lot of students keep asking questions about the concept of significant figures and they seems to be confused. And so I'm doing this video to help you understand, especially those of you who are my students online. Let's see what significant figures is all about. So what is significant figures in the first place? In a simple definition, we'll say that the significant figures of a number are those digits that carry meaning, contributing to its precision. It tells how precise a measurement is when taken. And in most cases, significant figures are used during measurements. Okay, during measurements. Now, let's look at some few rules that governs significant figures if you want to write it. The first rule is simple. All non-zero digits are considered significant. All non-zero digits are considered significant. So if I write this is two significant figures. This is 1, 2, 3, 4, 5 significant figures. They are all non-zero numbers or non-zero digits. So they are all significant. Okay, good. Then again, all zeros between non-zero numbers are also significant. So you see where the zero is in between non-zero number. So far as they stand in between, they are significant. So here I will say we have 1, 2, 3, 4, 5, 6, 7 significant figures. So this is 7 significant figures. And here we have 1, 2, 3, 4, 5 significant figures. It makes sense, right? Good. Let's continue. Rule number 3. Leading zeros are not significant. Take note, they are not significant. Anytime you have leading zeros like this, 0.000742, here only these three numbers are significant. So the whole of this number has 3 significant figures. Okay, so anytime you have leading zeros, they are always non-significant. But if I bring 1 here or 2 here, then the zeros here become significant. As it stands, without the 2, the zeros are not significant. Then look at this one. Here, how many significant figures do we have here? We have only 1, 2, 3, 4 significant figures, right? So let's take the next step. Point number 4, all zeros which are simultaneously to the right of the decimal point and at the end of the number are always significant. Let me repeat. All zeros which are simultaneously to the right of the decimal point at the end of the number are always significant. Example, look at this number. 3.67000. The 3 zeros at the bottom here are significant. So this number has 1, 2, 3, 4, 5, 6 significant figures. In fact, a bit tricky over here, so try to understand it. Because of the decimal point, this has or this number becomes significant. If we have 367,000, here we'll have only 3 significant numbers. The zeros here become insignificant. But if there's a decimal point, then all numbers that follows or the zero that follows becomes significant, right? So here, look at this. How many significant numbers do we have? We have 1, 2, 3, 4, 5, 6 significant figures. I hope it makes sense. Good. Then here, how many significant figures do we have? We have 1, 2, 3, 4, 5 significant figures as well. Good. Now let's take point number 5. All zeros that comes after non-zero number, okay, and there is no decimal point are not significant. So I gave you an example earlier. Example can be this. We see this one, 37,000. All zeros that comes after non-zero number like 37, which is non-zero number, and there is no decimal point, then those zeros are not significant. So here we have only two significant figures here. 37,000 has only two significant figures here. Then 144,300 has only 1, 2, 3, 4 significant figures. I hope it makes sense. Good. Let's continue. So this number, which is 43 million, will have only two significant figures. It doesn't mean when you are writing, you throw away the zeros. You not throw away the zeros, but then you have only two significant figures here. Beautiful. Good. So when I ask you to leave this number to one significant figure, you write 4, okay, then this 3 becomes 0, and you repeat all the zeros, but only one significant figure. All the zeros will be there, but it will be one significant figure. Now, based on these rules, let's see if we can quickly answer the following questions. How many significant figures are there in the following numbers? How many? For example, the first one. 1, 2, 3, 4, 5. 5 significant figures. What about the second one? I'm sure your guess is right. Only one significant figure is here for the second one. The third one, right? So this, and this are significant. So there are only 4. The first zeros are not significant. What about this one? Right, only 4 significant figures again, because 1, 2, 3, 4 are significant. Okay, you see here the zeros in between the number is significant, but the zeros that comes after, because there's no decimal point, are insignificant. So we have only 4 significant figures. Maybe let's take one example and see again. Now express this to 2 significant figures. What will you write? You can pause the video and try it. Okay, so we have 1, 2, 3, 4 already, but then we are talking about 2. So 1, 2 becomes the first 2 numbers. So it's going to be 1, 9, 0, 0. But because the 7 here is more than 5, we run it off, and it will add up to this to become 0, and this becomes 2. So the answer becomes 2,000. Okay, so that is 2 significant figures. What about this one? Write this to 3 significant figures. Good. So we are going to have 1, 2, 3. So we have 5, 5, 0, 4. But then because the next number here is 5 and above, we run it off to this, and that becomes 505. Then we bring, so that becomes our number. Okay, that becomes our number. But because this number here is going to be running off, so there'll be 0 here. Now in this case, all this number becomes insignificant, so you can choose not to write them. All right, maybe let me do the last one. Try this one. To 3 significant figures. Good. So 3, we are going to have 1, 2, 3, and all these numbers are insignificant for now. So the 4 here, which is the last one before that comes after the third number, is not up to 5, so we can't run it off. So the answer becomes 3.03. Okay, 3.03. Right. I'm sure this has really helped you to give you a fair idea about significant figures. Thanks so much for watching.